Well, hello. Here we are again for another round of coding Tetris, progressing my Tetris clone with Elm. And yeah, today is a nice opportunity episode because I get to talk about commands, which is a very central concept in Elm as well. And we have a very nice use case to showcase this concept. Like I'm promised, I will keep today's episode shorter than last week's. So my main goal, my principal goal for today is just to have some part or the active piece drop on the board by fake Tetris gravity, and for that we will use the commands, and I'm feeling hopeful that it takes less than an hour to accomplish that. So let's dive right in. I already started my build server or build script. It's not really a server, so it's not serving anything. And going to open the source file, main, looking all good. Let's see where we, okay, cool. Where we left off, the model is still only the board only, and I think we're going to need to add a new field here to actually track our piece that is currently falling, or the current piece that we have to place as a player. So let's just call it current piece, maybe. Current piece. And I was wondering, do I already have a data type for this? I forgot a bit what we did. We have a piece definition, we have position, we have rows, but we don't really have a type for this. So let's create something, and what I have in mind is I want to store a position and then like the assembly of tiles, I think we called it, like because let's just go back to see how I'll just wing it. So let's call this current piece, let's call the type current piece, because I don't really know, maybe a better name will evolve. And it's going to be also just an alias, because we just want to have like a struct with a few fields. Current piece, and what I know, I want to have a position in there, that's for sure. Position, and yeah, I think that's fine. Maybe we just go with that. And for now, we just assume the current piece is always the T piece, so that we can, and then we can detail it out later. So now that we extended the model definition, we also have to, we can actually just see what it will tell us, and it will tell us our init function is off because our initial model state does not have the added current piece field. So I'll just increase the size here a bit. Let's find the init function. It's here. And well, actually, I think I'm going to remove all of the stuff that we just introduced to see some pieces here, and we just go with the empty board as a start again. And next to the board, we also have to set the current piece. So current piece equals current piece. Let's go with the local expression right away. Current piece mute the Apple Watch. Equals position. And position was a tuple of integers, so we just put it to 5 for now, just to have something to start with. So let's see, what does it tell us? Oh, it compiles again, so that's great. Although I'm a bit confused why they are still because let's see, remove those. Let's see where we're rendering. View board. Did I call it board or board view? I don't know. Board view, yeah. And here we see like we also added some temporary pieces. Maybe I just keep this, but we don't use it. We just use the board we get. So board. Now we should have a nice empty board. There we go. And where do we call board view? We call it from here. So now obviously our board does not contain the piece that's falling currently, so we have to put it in there. So I think we're just going to pass it as well, current piece. So next to the board we also get the current piece, and yeah, let's just put this here. And I said we want to use, so now that's why I kept these expressions, because basically we can now recycle them, because we now place piece on board. We can just put our current piece dot position here. And there's an error. Board with pieces not defined. That is correct. It's just board. And also, of course, let's call this board with current piece to be extra specific. Board with current piece. The second argument, na. Why does it not want? Second argument in line 249, that is correct. Board with current piece. Is it not a board? Dot rows. Because we map over the rows. And there we go. At our nice position. Cool. So I think that's actually a good starting point for introducing the gravity, because we have a position, so we just need to change the positions in some way. And for that we want to use a kind of timer, an interval that gives us every second or so an indication that we are to drop the piece. Or actually maybe we implement the drop function first. No, we'll start with the timer. That's a good thing. And so yeah, timer. Let's look at what the Elm timer interval, very naive search. Maybe that's actually misleading. Time, task perform, interval, every. Yeah, we are using the time at time in, which means every second. Yeah. That sounds a lot. Okay. Ooh, and subscriptions. Yeah, that's tightly coupled to the commands and the subscription concept. So yeah, there's actually a page here in the manual as well. So let's see what they have to tell about this? La 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 la, sandbox, blah blah blah, element. Yeah, no, I think we just do it, and I explain while we go. So far we have seen the cycle of the Elm update of the Elm function is we have a model, we generate a view that can issue messages, and then we use the update function to use the old model state and the message to create a new model state, and then we create a new view from that. But the concept of something just spawning like these timer intervals does not really fit into there, because we are not really, it's not the user that is interacting with the DOM, it's just something that comes from the outside. And for that, Elm has this concept of subscriptions, and I have them already in the Tetris prototype here, but I just glossed over them not to distract you. But now we are going to have a closer look. And so subscriptions, let's see, it's part of this initial data structure that we are this expression that we give to the Elm runtime to do something. Like we have talked about all the other pieces, basically the init, the update, and the view, and now we are going to have a look at the subscriptions. And you see, so this function, like the signature, is basically kind of dictated by the other types that we introduced through our init and update function. So the model, it's a function that always transforms from our model into the subtype, and the subtype comes with Elm. That's basically the subscription, and it has a type parameter message. So this is so that means this is a placeholder that gets filled by our application with our message type. So the type that the update function consumes, because these subscriptions, you can think of them maybe like event listeners or event issuers. Like we're basically registering what kind of events we want to listen to, and we have to transform them into messages, because that's basically our way to snug into the usual life cycle. So basically we have this with subscriptions, we get this alternative mode to issue messages, but everything after that, it works just the way as the processing of a message that's created from our DOM elements would use. So we just issue the message, and then the update function takes the current model, the message, and produces a new view from that eventually. Cool. So let's look again at this thing that will eventually issue a message every second. We were just there. I just have to find it again. And there was something with every that looked very promising. Yeah, actually this is like perfect. Oops, where is it? Example right here. So that's exactly what we want. So basically this says our subscription is every 1000 milliseconds it will send the message tick. So that's perfect for us. We'll just dump this into here, copy, and then it will tell us what's missing. I cannot find a time every variable. That's because we didn't import the time module. So let's add this here, import time. Boom. What does it say? You're trying to put time, but I haven't. And here another wonderful example of the great error messages, that very helpful error messages that Elm is giving us. Maybe you want the time module defined, and the running this command should make it available. So all lazy here, dump it here. It's already in our indirect dependencies, and by just installing it, it will be moved to our direct dependencies. Yes, that's what we want. We start our build script. And now it says that like the original error message is gone, and it says it cannot find a tick variant. So this is very obvious if you have been coding a bit, but this this tick refers to a variant of our message type. So let's call this maybe gravity instead, or gravity tick instead of tick. So let's see where we define our message type. What did I say? Gravity tick. Awesome. And now it says, oh, it actually should not be just a message. It should be a function from time POSIX to message. So that means we have to add a parameter to our type. And that means that also turns basically this identifier into a constructor function that takes a POSIX time. Saving this, and now that's also very expected is that we introduced a new message. So now we also have to update our update function that for every message has to know how it transforms the model in combination with this message to a new model state. So let's do that. Just going to copy it from here. And I think we're just going to ignore this value for now. And well, for starter, we are going to do nothing when we receive this tick, just to get it compiling again, and this looks good. So basically, now what we want to do is we want to update the position of our current piece to be dropped one row below. So let's create a new function, drop current piece, and give it the model. And then I don't know, where are we going to drop it? Oh, here somewhere under the update function. It's kind of a helper to that. Drop current piece, piece takes a model and creates a new model. And again, just to keep it compiling, going to not do really anything for now. Save it, see if it's still compiling. Looks good. So now we can use another syntactic trick here, where we grab the current piece directly with the curly brackets. So that means instead of having to write model.current piece, I can just use like this, introduces a local expression to my function that takes just the field with this name, and introduces a local expression with the same name. So let's say calculate an updated version of this. Let's call it dropped piece, and we're going to take the current piece as a basis and update the position to, well, actually, we are going to destructure the old position from the current piece. So x.y is going to be current piece.position, and we're going to create a new position that is 1 row lower. And then we are going to update our model based on our so actually I still need the old model, so I'm going to introduce this as well. And now it's really arguable what is nicer. I can just as well, I guess, just have model and do this little dance here. Oh no, I liked it before like this. So now I can access the current piece from the model, but also the model as a whole expression. Basically, we are going to create a new version of this where the current piece is now the dropped piece. So now I have some as model. Maybe I have to introduce some parentheses for this. No, it really doesn't like it. What does it tell me? In. Ah no, that's actually completely the wrong place where I was looking. So let's undo this. I was missing a closing bracket here. And now it's, oh no, it actually was both. So now the formatting is right. And yes, look at this. Something is moving every second. So now we said the lowest row is the row with the lowest number. So that's a classic mistake here. So instead of increasing, we have to decrease the row number. And now, hallelujah, it's dropping. Cool. So this is all great. And technically I could end now because I said I only want to implement this. But I think we should use at least a bit more time to, I don't know, to maybe at least have the piece start at the top row. So it's an easy fix for now. Like there's so many things. We have to be able to move it and rotate it, and it should stop when it's at the lowest row. So yeah, let's fix the init first. Current piece init. Let's start at board height because that's the number of rows. So now it should drop from the top. Yeah, that's working. So actually, maybe we don't want to, obviously also we don't want to just drop L pieces. So eventually we have to be able to change out which kind of piece we're dropping. So I think I'm going to implement this. Because currently, if we go back to our model definition, our current piece definition is just a position. So obviously we want to have something here. And like we already have the piece definition, but we don't really want to drop a piece definition because once we rotate it, like where we could store the rotation separately, but I think we'll just, as a simplification, we'll just store a list of tiles that make up the current piece. And then when we rotate, we just change the position of those tiles, and then we don't have to store and recalculate the rotated tiles each frame. So I'll add the list of tiles here. And I think I want to have the color as well. Let's look up the piece definition again. Field color is the type for our color. Okay, cool. Let's add this here over here. Cool, save. Let's look at the compile errors. Something is off. Current piece is not really fully defined yet, so we have to extend our init definition. Again, current piece, and that's where we're missing. So let's say init piece. Oh, we can just be lazy and just write it all out. Tiles is tpiece definition. That's the definition, and it has a tiles field, at least I hope so. And same for color. Well, I'll just see if that works. Yes, compiles, but obviously that's not a T-piece. And that's because we currently have hard-coded the LPs to be rendered. So let's look at the board view function. And we have this place piece on board. And it takes a piece definition, so that's not really useful. So I think, or maybe it comes in handy again. Oh no, I think this is actually we don't need this, do we? No, we don't need this anymore. We are going to upgrade this because we want to place the current piece on the board. So let's go here, current piece. And technically I could use the squiggly brackets destructuring thing again, but just for the sake of doing something differently, now I'm going to go with this one again. So, and we were translating the tiles of our piece definition, but since we don't have the piece definition anymore, we are just going to replace it with our current piece. And we also we have X and Y. Before we were passing in a position explicitly, and now we are just going to use the position from our current piece. And yeah, I guess the color should be used in here as well. Let's just compile it and let the compiler help us. Old board 217. What's going on there? Old board. Yeah. To remove the piece definition parameter from here. I cannot find a piece def variable in line 2148. Boom, field piece def color. So, and that's why it was very practical to have the current piece have basically a similar signature. And now we just have to fix our call of that function. Let's jump to this line and we say place piece on board, current piece. I know that's just what I added. The piece definition is not needed anymore. Let's have a look. And we have a dropping T piece. Isn't that wonderful? Cool. So today we hit exactly half an hour, and since I want to keep this a bit lighter than last time, I think I stop it from here. And yeah, hope I see you again next week. I haven't prepared my blog post where I share my recording yet, but make sure to check out blog.accelerator.de, where you can find the recaps for the previous episodes. And towards the end of the week, I will also do a little recap where I'll hopefully also explain a bit better the command and the command. Actually, we haven't seen command. We only have seen subscriptions. So sorry for not telling the truth in the beginning. But I write a bit more about the subscription again as well. Then until next week, have a nice one.